Osmosis is essentially a type of diffusion, more particularly diffusion of water across a semi-permeable membrane. So osmosis is or works in the same way that diffusion does, but it's just diffusion of water across a semi-permeable membrane, like a cell membrane. So some people often get a little bit confused with osmosis, even though it works in the same way as diffusion, because it's a type of diffusion. It's a passive process, it's a passive movement of water, but it moves from areas of low solute concentration to high solute concentration. So where we have in diffusion, we have molecules moving from high to low concentration. In osmosis, water is going to move from areas of low solute concentration to areas of high solute concentration. Now the reason for the switch in moving from low to high is when we have a low solute concentration, it means we have a higher water concentration. When we have a higher solute concentration, it means we have a lower or lesser amount of water. So it's still moving from high areas of water to low areas of water, but a high area of water or an area with a high percentage of water is more kind of easier to tell by looking at the solute concentration. So let's have a look at how that actually works with a cell. So let's say we have a cell here, and inside the cell we have a concentration, a salt concentration of 10%. So the solute concentration refers to the amount of a substance dissolved into water, a solute in that water. So we can have salt being our solute, and inside of the cell we have a solute concentration of 10%. So 10% of the water inside the cell is made up of salt. Let's say on the outside of the cell we have water that is 20% salt. So we have a cell that's placed in salt water with a higher concentration of salt. So we can say that it has a higher level of solute or higher percentage of solute than inside of the cell. So what that's going to mean is that inside the cell we have a greater percentage of water compared to outside of the cell, which is going to be 80% water. So what's going to happen is water is going to want to move from where there's more water to where there's less water. So this is going to mean it's going to move from an area where the solute concentration is lower to where the solute concentration is higher. So in this example, inside of the cell has a greater amount of water and a lower than 10% salt concentration or solute concentration compared to outer cell, which has a 80%, so a lesser percentage of water, and a higher percent, 20% of salt, a higher solute concentration. Water is going to want to move out of the cell in an effort to reach equilibrium. Now, if we were to look at another example, let's say that the solute concentration or the salt concentration was 30% inside the cell, and outside of the cell we had 15%. It means that the solute concentration outside the cell is lower, there's going to be more free water present, and we will see H2O, water, moving into the cell. Now remember, this is a passive process. It means that no energy is required. So this happens without the input of energy. Let's take a look at how this affects plant and animal cells, because it does affect them in a similar way, but it can have more dire consequences for animal cells in comparison to a plant cell. Now, under normal conditions, what we'll see is in a plant cell, we'll have water moving into the cell, we'll have water moving out of the cell, water moving out of the cell, and it will be more or less at an equilibrium. So if a cell is placed in a solution which is of similar solute concentration to itself, we say that this is an isotonic solution. And we can also label this as normal or regular conditions here in the cell. Now what we'll see, if a plant cell is placed in a solution which has a lower solute concentration or a hypotonic solution, what we'll see is water will want to move into the cell. So if the solute concentration is lower outside of the cell, it's going to mean that there's more free water, and it will move along this concentration gradient from where there's more water to where there's less water. And finally, if we have a hypertonic solution, this means that the solute concentration is higher outside of the cell and water will be departing or making its way out. So when we have a plant cell starting to swell with water, we call it turgid, and then we can have a shriveled cell if water is departing. Now, because a plant cell has a cell wall, we'll see the cell membrane start to swell or shrivel inside of that wall, depending on whether it's taking on or relinquishing water, but the plant cell is able to pretty well keep its structure because of that strong cell wall, keeping things rigid in place. If we look at animal cells, this is slightly different because they don't have a cell wall. So this lack of cell wall can mean that taking on too much water can be an issue for an animal cell. So if we have isotonic conditions, or cell is in isotonic solution, same again, we will see water entering and exiting the cell because they have similar solute concentrations inside and outside. When an animal cell is in water which has a lower solute concentration than inside the cell, it's going to take on water. So water is going to want to travel from the area outside with a lower solute concentration, more free water, into the cell, and it will start to swell. So we say that this cell is lysing. The problem with this situation is if a cell has such a difference in concentration, then what's going to happen is it will take on so much water that it can eventually burst if equilibrium isn't reached shortly. Because it doesn't have a cell wall, then it doesn't have this kind of rigid structure keeping it in place. Finally, if we have a cell that's placed in a solution which has a higher solute concentration than it, we're going to see water leaving. So water going to where the solute concentration is higher and there's less free water. So we say that this cell is shriveled, much like the plant cell. So overall, even though some people are a little bit confused by it because of using the low solute concentration to high solute concentration terminology, basically osmosis is just a diffusion of water across a semi-permeable membrane from areas of low solute concentration to areas of high solute concentration, or from where there are areas of lots of water to where there is not that much free water.